I want to briefly introduce multiple linear regression to you as an idea, and then you can watch the video on what multiple linear regression is all about. So, we first really started looking at simple linear regression in chapter 4, and then we really learned about interpreting R squared in there and using it to decide just how good of a job our model did. And then we discussed inference or regression in chapter 15 and explained most of the other numbers that the computer regression table produces for us and how they could really help us decide whether or not our model was significant. But the simple linear model just really isn't rich enough to deal with complexities that really happen in the real world. So linear models almost never account for, well, simple ones almost never account for all the variation in the data, which is exactly what R squared was telling us. What we're hoping to do as we proceed forward is to add more predictors to the model that can help us account for more of the behavior and the response variables that we have. And the idea is that the linear model that accommodates more predictors naturally will produce something that is sensical to us. So we all have been using Minitab as our statistics program to produce the single linear regression so far, the simple ones. And naturally, we're going to add more variables to this and still use it to predict a single variable in a form of regression. But the unfortunate part about this is that it's really hard to visualize how this is going to happen. You have a single line cutting through space that represents multiple different variables, and the second you hit something above like three-dimensional, you can't see it easily. The fortunate part of this would be that chapter 15, all of the truths that we see there still hold. R squareds will still give us the fraction of variability, and it will account for how much of the regression is doing, but it's going to need some fixes because of some of the problems with using R squared to judge our model. The coefficient tables that we have with the standard errors and the t-statistics and p-values for each coefficient are still useful and still have the same interpretation or helpful. But the interpretations get slightly more complicated when you have more variables present. So the regression coefficients have this subtle difference in interpretation that needs to be understood. And we're going to try to carefully describe that in this chapter and what the multiple coefficient for linear regression means. The assumptions and conditions will also be given renewed attention. And this is because when we go through certain assumptions, they will need to be done in a certain order in order to make sure that our conditions are met and the computer results are useful. So in particular, like the linearity assumption is now an assumption about multiple regression model. That changes. It's no longer just two variables that we're looking at. It's a little bit harder to check this with the corresponding conditions. And it's really going to matter the order in which we do things. And the most important new concept is going to be how we interpret multiple linear regression coefficients. A coefficient measures the linear association between the predictor and the response variable after allowing for the linear effect of the other predictors that are present. So order super matters when it comes to doing this. So don't let yourself like casually interpret this. There's a lot of meaning behind what's happening here. And as we go forward into 18, we're going to learn some of the best practices and methods on how to do this. So 17 and 18 are almost a merged item, and I really hope you look at them together and not just individually. And then after that, we're going to move on to the analysis of variance, which is honestly, along with multiple linear regression, the foundations to, well, the most widely used statistical methods in the world. These two are going to be the biggest topics about what we learn, and they merge very naturally with what they're trying to tell you. So that's what we're getting into. I'm excited. We're almost done. So, take a deep breath. I hope you like multiple linear regression. That's one of my more favorite topics. Of course, I kind of like all of them, so maybe I'm biased. Guess we'll find out.